My name is Brody Stevens, and I'm a second-year student at New York University. I work in the Gertner Lab under the mentorship of Dr. Kellen Chen, and our lab focuses on wound healing and tissue regeneration. And our main research question in the lab is, what are the molecular mechanisms behind wound healing? Just to give you a little quick tour of our lab, this is some of our benches and working area. This is where we do a lot of our staining. And this is where we keep our hood, where we do fume and hood work. Today I want to share with you an exciting project we're working on to tackle a critical health issue, liver fibrosis. Liver fibrosis is a condition where excessive connective tissue builds up in the liver, often leading to cirrhosis and liver failure. This can result from chronic liver diseases such as hepatitis, alcohol abuse, and non-alcoholic fatty liver disease. Thiocetamide, carbon tetrachloride, and diethyl nitrosamine have all been explored for methods of inducing liver fibrosis, but the thiocetamide-induced liver fibrosis mimicked humic fibrosis most closely. Diethyl nitrosamine displayed liver cancer, and carbon tetrachloride was closer to replicating human liver fibrosis, but thiocetamide was deemed most similar to human fibrosis as it led to chronic liver injury and subsequent liver fibrosis. We inject the mice with thiocetamide for a certain duration of time to induce liver fibrosis, where we then let the fibrosis resolve, and then collect the tissue and liver and analyze it using serum analysis, histological analysis, MRI mapping, single-cell RNA sequencing, nanoindentations, and other various experiments to gather comprehensive data. This liver is from a C57 mouse that received 10 weeks of thrice-weekly TAA plus saline injections. Looking at some of the key features, in the first image we see blue staining, and in the second image we see purple staining. The presence of extensive blue and purple stained fibrous tissue indicates collagen deposition, a hallmark of fibrosis. The fibrotic bands are thick and widespread, suggesting advanced fibrosis. Most importantly, in both provided histological images, you can observe fibrous bands stained blue in the first image and purple in the second, extending from one portal tract to another, forming bridges. This is indicative of portal-to-portal bridging fibrosis. Working closely with liver specialist Dr. Belinda Sun at the University of Arizona and referencing the Ishak scale, which assesses the level of fibrosis, which scores range from 0, no fibrosis, to 6, cirrhosis, our model presents between a stage 3 and 4, but closer to 4. This is very promising, and more experiments can lead us to mimic a more cirrhotic human liver. Although we've learned so much with this experiment, we still have so many remaining questions. Thank you.